Now that we have learned about inequalities and how to solve them, we're going to take this one step further and look at what is called a compound inequality. And you can think of this just like two inequalities that are smushed together. There are two versions of this. You can have and or, and we're going to look at that in just a minute. It has two inequality symbols in the same expression. This is how you know that you have one of these, if you have two inequality symbols in the same expression. And you can think of it as saying two different things in the same sentence. So just like a compound sentence is when you take two sentences and combine them together into one sentence and somehow join them together, this is the exact same thing. You're taking two inequalities and joining them together with either and or. So before we go any farther here, I want to look at this. Okay, think about this. Let X be the ages of middle school students. Okay, and so we have students from 5th through 8th grades. So this is 5th through 8th. So that's 4 grade levels, right? 5, 6, 7, and 8. So there are 4 grade levels. Okay. What is the youngest that somebody could be in middle school? Well, the youngest age is 10, right? And then what is the oldest? 4 years past that would be 14. So all the students in middle school are between the ages of 10 and 14, right? So then if X is these ages, if X is the ages of the middle school students, and this is kind of where it can be, right? 10 to 14. then what would X be written as? How can we write X using our algebra skills we're learning if it can be more than one thing, right? Normally we're thinking about X as being a single value, and so we might say that X is equal to 10, but it's not just equal to 10. X could also be equal to 11 or 12 or 13, or 14. And we're saying that these are all the possible values for students' ages in middle school. So this is really, X could be many different things, not just one thing. And that's, of course, that's the idea of what an inequality really is that when X is equal to more than one thing, right? It's equal to a range of things. And so this is a range. This is the range of 10 to 14. That is really what X is. It's the range 10 to 14, which means it can be all these different things here. Okay? But let's think about this. If we're saying that middle school students could be between 10 years old and 14 years old, then we can really think of this as a lower limit. So the lower limit is what? 10. Obviously nobody younger than 10 is going to be in middle school. We do not have any 7-year-olds in middle school. So we know that X definitely has to be greater than 10, right? It has to be greater than 10 because you're not going to be in middle school. Nobody's in middle school if they're 9 or 8 or 7 or lower, okay? Or younger, I mean. So the lower limit is X has to be greater than 10. So if we're looking at this on a number line, right? If we're looking at this on a number line, we would find 10, okay? And since X has to be greater than 10, it's going to be, or it could be equal to 10 because we have some 10-year-old students. Then we're going to fill in at 10, and we have to go up. Oh, I meant to be doing this in red. Sorry. We would fill in at 10, and then we would be going up because we know that all of these people here at 9 and 8 and 7 and 6 and on back, these are not part of middle school. So we know that those cannot happen. So it has to be 10 or, so it has to be 10 right here or this way, right? So that's the lower limit. And for the same kind of a reason, we have an upper limit because we don't keep students in middle school if they get to be 15, 16, 17 years old. I'm certainly hoping that they're in high school by then. And so X has to be less than or equal to 14, right? Because if we graph this and we find 14 up here, like that, we know that the oldest student we have in middle school is 14. So all of these other people up here that are 15, I should make this longer. Let me extend this out a little bit. Okay, so here's, maybe a 15-year-old and a 16-year-old and a 17 and on and on and on. All of those people are not in middle school, right? So we know that it has to be 14 or less. Okay, we have to go this way. All right? And of course we can fill it in because we do have some 14-year-old students. We can fill in this dot because we have some 10-year-old students. Okay? So it can actually be equal to the numbers 14 and 10. But then notice that it has to go this way from the upper limit, and it has to go this way from the lower limit. And as you can kind of see here, what's happening? Well, I'm just going to extend this graph, and let's just do this in green so we can see the difference here. Let's just extend this graph right here and kind of go across a little bit thicker. And then what do we have here? We have 11, and we have 12, and we have 13, and then we have 14, and we have 10 down here. So really what we're getting at, I'm kind of extending this graph, and I'm just interested in looking at this part of the graph. I'm just interested in looking at this section right here. See where I'm getting at with this? I'm interested in this section right here where I have 10 and I have 11 and I have 12 and I have 13 and I have 14, and those are the possible ages of people, just like we saw here. Those are exactly the same, 10, 11, 12, 13, 14, 10, 11, 12, 13, 14, that we're really interested in. So if you notice, from the 10 point of view, we're going up the graph, and from the 14 point of view, we're going down the graph. So what we have here is we have this one and this one. We have two different inequalities that we have to combine together. And that's exactly what we're doing. We're combining two different inequalities and we're smushing them together. Okay? So, all together now, what is x? Well, x is what? X is greater than or equal to 10. Notice here, I have this same statement. So that statement right there is the same as what I wrote right here, okay? That's exactly what I wrote right there, even though it's backwards. But notice that the alligator is eating the x and the alligator is eating the x. So it's still the same thing. This says x is greater than or equal to 10. This says x is greater than or equal to 10. And then over here, but x is also less than or equal to 14. And so this part of the inequality, from there over to there, is exactly this. So what we have here is we have an inequality with two inequality signs in it, and it's essentially two different statements that have been combined together. So we have this part here, which says that x, and what I'm doing here is I'm just kind of like drawing a little box around this like that. X is greater than or equal to 10, and remember I said it's going to be and or that's joining these two things. So x is greater than or equal to 10, and x is less than or equal to 14, which is this right here. And so notice where they overlap. They overlap right here where the x is, right? I've got the green box going this way, and I've got the blue box going this way, and they're overlapping right there at the x. But I could really just separate that out, and I could extract this inequality, and I could extract this inequality, and put them back into two different inequalities, and say, yes, this condition, the lower limit right here, has to be met, and the upper limit condition also has to be met. Both of them are required to make an accurate statement about x. Okay? I have to know that it's greater than or equal to 10, and I have to know it's less than or equal to 14. Okay? Both conditions have to be met. And so that's what I've written here is a compound inequality using the word and I have two inequalities that I have combined together. So let's graph this. Well, normally we would have, a 0 in the middle, but we don't necessarily need that because what we need here is we need a 10 and we need a 14, right? And both of these are equal to, this is equal to, this is equal to. So we know that the dots on both are going to be filled in, right? And then we're interested in the space in between them. So right there is exactly what, and of course I could draw this in if I wanted to, 11, 12, 13, 11, 12, 13. And so what I'm looking at here is the graph of this inequality. And notice I'm not going up here to infinity in either direction because the ages of the middle school students are not going up to infinity. If this is the ages of middle school students, yes, it has to be 10, 11, 12, 13, or 14. Nothing greater and nothing less. So that's a graph of that inequality. All right? So let's look at an example now. Let's look at an example now. And that was an example of an AND statement. Okay? So let's look at an example of an OR statement, which means that they don't overlap. Did you notice how these kind of overlapped? My lower limit was going up and my upper limit was going down, and so I end up with this section in the middle where they both were kind of going like this, and I end up with this section in the middle that's what's covered. An OR statement is a little bit different. So in this scenario here, m minus 2 is less than negative 8, or m over 8 is greater than 1. Well, let's look at these individually. Let's solve both of these for m. So we're going to add 2 and we're going to add 2. All right, so that when we balance this, the negative 2 and the plus 2 go away, and I have m, and I haven't changed the sign, and I have a negative 8 plus 2 is a minus 6, so I know that m has to be less than negative 6, or, of course, here I'm going to multiply by 8, so those cancel, and so I have m is greater than 8. Now think about this. M is less than negative 6, so this is a negative number and it's less than, so it's going to keep on going down, right? Or m is greater than 8. This is a positive number and it's greater than, so it's going to keep going up. So let's look at what these would look like individually. If I tried to graph this here, m is less than negative 6, I would find my negative 6 right there, and it would be an open circle, but I would be shading this way, right? Because it's less than negative 6. And then here's 0 right there, it's less than negative 6. And here, graphing this, here's 0, here's 8, and it's an open circle, but I'm going up because it's greater than 8. So what's happening here? I've got my lower limit that's going down, and my upper limit is going up. These are never going to cross, right? That's why it has to be OR, because if it was an AND statement and I had to graph both of these together, there's no place that they both work at the same time, because this is just going towards the negatives and this is just going towards the positives here. So they're kind of diverging from each other and they're never overlapping, and so the graph looks the same way, and that's why this is OR. This could never be an AND statement. Here's 0, here's negative 6, and here's 8, right? And they're both open. They're both open. So here's open, and this one is going down because it's less than that, okay? And this one's going up because it's greater than that. And so that is what my graph looks like for this. And they never overlap because there's no place that this one and this one both exist. So this is what the graph of an OR statement looks like. Okay? Let's look at a couple other examples. Okay, so here is negative 1 is less than 9 plus n is less than 17. And the way you can also say this, okay, the way you can also say this, and I'm going to write this down over here, but you don't necessarily need to do this, but I'm just going to write this down over here. If you think about it, this is saying 9 plus n is between -1 and 17. That's what this is saying. 9 plus n is in between -1 and 17. That's what that's saying. So we can do this just like we did with the age example. Notice that what I had here is I had this little green section, right? I had this little green section was one of my inequalities, right? And then I had the blue section was another of my inequalities. It goes this way. So I can split this apart, and I could sever this right near the x, and I can have this statement and this statement both come out of it. And that's what I'm going to do right here. So the green statement here would be this, and the blue statement would be this. You see that? So my green statement would be -1 is less than 9 plus n, and my blue statement would be 9 plus n is less than 17. Okay, and then I just solve these. I can just solve these. I mean, these are just single inequalities now. So I want to solve for n, so of course I have to subtract 9 and subtract 9. When I balance this, I get a -10 is less than n, which is the same thing as saying here, that n is greater than -10, right? I'm just flipping the whole thing around. Here, of course, I still need to subtract the 9, and so when I balance, I have n, not flipping the sign, 17 minus 9 gives me 8. So this one's already arranged correctly. N is less than 8. Okay? Or n is greater than -10. So let's think about what this means. Let's think about what this means. N is greater than -10, and since this was combined into one big long inequality like this, we know that this is an AND statement. So they both have to overlap at some point. It will look like this. Oops, excuse me. It will look like this where they come together. It will not look like this where they diverge from each other. This is OR. When they diverge like this, it's OR. When they come together like this, it's AND. So this is an AND statement because you can't write an OR statement altogether like this. This is an AND statement, so they are going to overlap. N is greater than -10, so here's -10. So there's that. It's an open circle. Let me zoom in real quick. Actually, I don't need to zoom in. It's greater than -10. It's an open circle. This is less than 8. Still an open circle. And then since I'm greater than -10, I'm going this way, right? And I'm less than 8, so I'm going this way. And then I run into the other end of my barrier there, and that's what the graph looks like. Okay? Let me zoom in so you can just make sure you see that well. Even though I said I wasn't going to zoom in. See that? If n is greater than -10, that means I'm filling in here and I'm going this direction. And if n is less than 8, that means I'm filling in here and going that direction. So that's why I have this section in between the two, right? Okay. What about 2x is less than 10 or x over 2 is greater than or equal to 3? Okay, so this is an OR statement. This is going to diverge. So let's solve each of these individually. Okay, and I'll keep doing this in green and blue. So my green statement is going to be 2x less than 10. The blue statement is going to be x over 2 greater than or equal to 3. So here, of course, I'm going to divide by 2. Divide by 2. Over here, of course, I need to multiply by 2 and multiply by 2. So these cancel, and I've just got that. and here I've got that. So x is less than 5 and x is greater than or equal to 6. So of course if I'm 6 or greater, or if I'm 5 or less, obviously these are not going to overlap. We don't expect them to. This is an or statement. They're going to diverge. So let's think about what we have here. Okay? So if x is less than 5, then it's going to be 5. It's an open circle here. X is less than 5, so we're going to go this way. Right? And then if x is greater than or equal to 6, then we have 6. It's filled in circle, and we're going greater than. And notice that I can have these mix and matched. I can have an open circle and a closed circle in the same inequality, and I have that one here. It's perfectly okay to mix and match them like this based on what you need. If you have one that doesn't have an equal sign, then it's an open circle. If you have one that does have an equal sign, then it's a closed circle. You can have them in the same problem. Absolutely perfectly okay. And so here's what we've got. We've got x is less than 5, which is this one down here. And then we've got x is greater than or equal to 6 right there, which is exactly what it is. You know, here's the 5. You're going this way. Here's the 6. It's equal to 6 and greater than. Okay? So that's what that looks like. Okay. Let's look at some of these. And I can give you some complicated ones, you know, big deal. Just means that I want you to do a little bit more algebra. Okay, so over here we have negative 10b plus 3 less than or equal to negative 37, or, right, 3b minus 10 less than or equal to negative 25. So here we have negative 10b plus 3, and it's less than or equal to minus 37. Of course, to solve for the b, what do we have to do? We're going to subtract 3, subtract 3. So this is negative 10b, and this is going to be negative 40, dividing by negative 10, dividing by negative 10. So b, and I'm flipping the sign here, none of that changes. I'm flipping the sign there, and I get a 4. So b is greater than or equal to 4. Okay? Or, and again, this is an or statement. Or, and here's my blue, the blue one, 3b minus 10 and negative 25. So of course we're going to add 10 and add 10, and then we're balancing, and we're getting a 3b, and we're not flipping the sign. Negative 25 plus 10 is minus 15. Just dividing by 3, dividing by 3. So b, again, we're not flipping the sign here, is negative 5. And of course, and this is or. Remember, this is or. This is still or. It's all or. And we expect to have one where the alligator's eating the bee and where the alligator's not eating the bee. That's what we want, right? We expect to have one of each. One tells us to go one direction, the other tells us to go another direction. So on the green statement, b is greater than or equal to 4. So here's 4. b is greater than or equal to 4. So here's 4. It's a filled in circle, and it's greater than. Right? And here's b is less than or equal to negative 5. So we have less than or equal to negative 5. So here's negative 5. It's filled in, and it's going down this way, right? So that's the one we expected it to diverge because it's an or statement. Let's look at one more conjunction. A conjunction is where you have and. We can even have this as an and statement and literally written out like with and. That's perfectly fine. Okay, that's perfectly fine. If it's an and statement, you expect it to converge over each other, and you have one where it comes together like the middle schooler problem. So let's just look at these. My green statement is over here. My blue statement is here. Okay, negative 1 plus 5n greater than negative 26. 7n minus 2. Great. Okay. So what are we going to do here? We're going to add 1. Of course, we then have 5n. We're not changing the sign, and we get a negative 25. Dividing by 5. We're not changing the sign because we didn't divide by negative 5. So n is greater than negative 5. Greater than negative 5 means we're going to be down here at negative 5, and we're going to go up this way. Okay? And I'll actually, just to show you a different way to do this, I'll actually go ahead and do this. So this is an open circle, and we kind of start shading this direction. I don't want to shade very far because I don't know where I'm going to stop up here. Okay? So now let's add 2, balancing. We get 7n and 14. It's clear now that we're going to be stopping at this 2 right here, but we'll just finish it all out. So then n is less than or equal to, oops, excuse me, it's not blue anymore. Okay, n is less than or equal to 2. So here's 2. That one is filled in, and so then we're going in between here, and here's an example of one where one end of it is open and the other end of it is closed, and that's perfectly okay. So let me just zoom in so we can all see this really clearly here. N is greater than negative 5, and it certainly is, and n is less than or equal to 2. Okay, and it certainly is. So just look at that again if you need to convince yourself of that.